Hello, in this video I will do a quiz on first order linear differential equation given initial value. So uh, we got to solve for this differential equation, this linear differential equation with the given initial value. So we have x dy dx minus y equals x of y1 equals 2. Okay, so what we have to do first is put it in, this is a linear. We got to put it in standard form, so I have to get rid of this x. To do so, I'm going to divide both sides by x. Okay, so this x cancels, you're left with dy over dx. And then this is negative y over x equals to 1. Okay, then what I would do is, it is in standard form, but I could rewrite this a little bit better. I can rewrite this. This is the same thing as 1 over x times y equals 1. So that's going to be helpful when you find your p of x and e of x. So now we have it in standard form. Now let's figure out our p of x and our q of x. So my p of x is basically this whole thing right here, which is negative 1 over x. And then my q of x is everything on the right, which is just 1. Okay, so now I got to find my my integrating factor. So it's going to be I of x equals to e to the integral of px dx, correct? And what is my p of x? Is negative 1 over x. So it's going to be e, the integral of p of x, which is negative 1 over x dx, correct? Okay, now how do I take the integration of this? How do I take the integration of negative 1 over x dx? Well, you have a constant, so you can take that out. You have 1 over x dx. And then what is the integration of 1 over x? It's just the ln of absolute value of x, and then you have a minus. So this simplifies as e integration of negative ln of absolute value of x. And what we do is, do you see this minus negative 1? You can rewrite that as a power. So this could be expressed as e to the ln of x to the negative 1. You don't have to put the absolute value. So then what do you see that cancels? The e and the ln. So you're just left with x to the negative 1, or you can say it 1 over x. That's the same thing. Okay, now let's start writing out our equation. Our equation is going to be y equals 1 over your integrating factor, bracket, integration of ix qx dx plus c, bracket. Okay, so I think we have everything. We can just start writing it out. So it's going to be y equals 1 over ix, which we said was x to the negative 1. But let's simplify that before we distribute that. It'll make it easier. What is 1 over x to the negative 1? Well, that could be expressed as 1 over x, right? This x to the negative 1 can be expressed as 1 over x. Now we have a complex fraction. This one is your numerator. This 1 over x is your denominator, correct? So we can rewrite this as 1 divided by 1 over x, cross multiply, so 1 times x is x, and then 1 times 1 is 1, so that's just x. Okay. If you want, you can just rewrite this as, so this 1 over x to the negative 1 could just be expressed as x. Okay, and then it's the integration of ix, which is x to the negative 1, and then our q of x, which we said was, 1. And then you have this dx plus c. Okay, now let's simplify this part right here. So that simplifies as integration of x to the negative 1 is 1 over x. And then you really don't have to put this 1 because it's a constant. And what is the integration of 1 over x? It is the ln of absolute value of x, or you could say ln of x, same thing. So your equation is going to be y equals x bracket ln of x plus c. Should we FOIL out the x? Yeah, that's fine. This would be x ln of x plus c of x. Now what we could do is plug in the initial value of 1, 2. So you're going to find your c by placing your coordinate. Your y is 2, your x is 1, ln 1 plus c, and then x is 1. And what is the ln of 1? It is 0. So 0 times 1 is 0 plus c. So that means your c value is 2. Okay, now we can put it in our final equation. So our final equation is this, but now you can put the c value. So your final equation is y equals x ln of x. And then your c is 2, so it's 2 times x. Okay, so that is your final equation for this linear differential equation. Okay, so that wraps it up for this quiz.